Alright guys, on Wednesday what we did is we created a class and we tried to follow some rules for the important things to do when you create a class, which include things like add a constructor if it helps, if it makes the class easier to use. Add a toString to convert it easily to a string for display. Data private. Methods public. Getters and setters. And we're going to add one more, a toEquals method. Not two equals, excuse me, just equals. An equals method so that you compare two objects. If you have two students and you want to see if they're the same, you write an equals method. Because you just can't do S1 equals S2. All that'll do is check to see if they're pointing at the same memory, not if they have the same context. Then it's up to your equals method to decide what makes two students the same. Do they both have the same student ID? Yeah, maybe that's easiest. Or are you going to compare all the members of the class? So we did some inheritance. We created a student class. That was our so-called superclass. It's a class that was inherited from. Then we created one called graduate, which extends the student. It inherits everything from the student class, which made this one the subclass, also known as the parent class and the child class in some textbooks. Student is the parent class, graduate is the child class. Now, one difference between this language and C++ is that in this language you can only inherit from one class. And that class can only inherit from one class. And that class can only inherit from one class. Whereas in C++ you could inherit from 20 different classes if you want. Now, the developers of Java decided that that made things way too confusing. But you could still get some functionality defined in it using a different form of inheritance called implements. And what implements does is you create something known as an interface. An interface is an abstract class, which we haven't really talked about, that defines methods that your class has to implement. First, let's talk about abstract classes. So an abstract class, you define it with the abstract keyword. It may have abstract methods, it may not. An abstract class cannot be instantiated. We've seen an abstract class earlier. I don't know if y'all remember when we were using stacks and queues and stuff like that. Why did we do queue whatever equals linked list? Why did we have that linked list word? Because you cannot create the queue. The queue class is an abstract class. So what we're going to do, define an abstract class named shape. We're going to keep going back to circles and squares and stuff like that. And all this one has is a public method called getArea. If we want, getArea can actually do something. We could make it return a 0, or something, because we don't have any data right now. Or we could just say, oh, by the way, this is an abstract method. An abstract method is one that whatever we define that inherits from shape, that extends shape, has to implement, or else it will not compile. So let's make a circle that extends shape. Right now it's going to complain. Circle is not abstract and does not override abstract method. We have defined a class that extends shape. We either have to mark this one as abstract as well because we're not going to fill in that method, or we have to fill in that method and then we don't have to declare it as abstract. So we're going to actually do that. Now we're really going to kind of do the absolute minimum here. Int radius is equal to 3, and then get area, public, double, get area, return pi r squared, math dot, pi times radius times radius. Everything that we define that extends shape, if it compiles correctly, is guaranteed to have a get area method now. That wasn't true the way we had implemented inheritance before. We had done extends and we picked up some methods that were part of the superclass, but we didn't guarantee that the subclasses had their own private implementation of them. They could pick up whatever was here without replacing them. And in this case, each shape needs its own get area method. So we're saying, I don't even know how you do a get area, but you better include one or else you won't compile. And so until we added that override, it wouldn't compile, unless we created the word abstract. Added the word abstract to it, which would also make circle an abstract shape. And then anything that extended circle would still have to define that method. Well, if we come down here and we try to create a shape, it's an abstract class and it won't let us. Shape S1 or SH1 is equal to new shape. We're going to wind up commenting this out anyways because it's not going to work. It'll say shape is abstract, cannot be instantiated. So an abstract method is one that must be overridden, implemented in a subclass. Any class that extends the superclass that contains that method. An abstract class is one, or we should say, if you have an abstract class, method, the class must be abstract. So I can't get away with going up here and deleting this word abstract. It says shape is not abstract and does not override abstract method get area. Well, of course it can't override it. It's defined right there. Anyways, if you have an abstract method, you need to make the whole class abstract. The reverse is not true. If you want, you could add a method that does something. I don't know what. Public say hi. System.out.println. Hello. Public void say hi, Now every class that extends shape already has that method and it's already provided. We don't have to override it. Circle inherits that. So down here in main, let's create a circle. Circle C1 equals new circle, and then let's print the area. System.out.println area equals plus C1 dot get area and let's see if it prints out whatever. The radius is 3, so we should see 3 times pi, about 27, 28. Okay. So that worked. Where did the get area method come from? Well, in this case, it came from the circle class. It didn't have to go any higher up the hierarchy to do it because it's defined as abstract here. But if we also call circle.sayHi, C1.sayHi, it says hello. Well, it ran up here. It looked. Was there a say hi method inside circle? Nope. So we better keep going on up the inheritance chain. We check shape. Yeah. There was a say hi there. So abstract classes are kind of neat because you can define methods in them. You can declare, oh, the classes that inherit from this had all better implement this method. Why is that useful? Well, we're edging towards polymorphism. Polymorphism is when you have functions with the same name that behave differently based on what kind of data they are. Get area differs. The formula differs based on whether it's a circle or a square. We may as well define a square. Class square. What's next? This one's also going to be a shape, so what's my next keyword to add? Extends shape. We need some kind of data to poke along with, so int side is equal to 4, whatever. And it's giving us an error because it's not compile worthy yet. The error is does not override abstract method get area, meaning we have to provide a get area. Public double get area. Don't ask me why I didn't make side and radius doubles, whatever. Return side times side. So I'm going to make a square. Square S1 equals new square. I'm going to copy that system.out.println and that C1.sayHi so I can just change those C1s to S1s. So the first object had an area of 28. The second object had an area of 16. 4 by 4 is what we defaulted the size to. Where'd that go? Oh, here he is. So that's the idea of abstract classes. They can provide functionality like sayHi does that applies to everything that inherits from them, or they can just declare methods that have to be implemented. That leaves the work to the inheriting class. The reason you do that is so that you can guarantee that every one of the subclasses has the appropriate implementation. We want every shape to have a method called getArea. So why is that important? Because we could do something like this. We're going to make an array list of shapes. Array list shape slist equals new array list. We could add both of those things to it. We better import the array list. So slist.add our circle, slist.add our square. And now we're going to run through our array list and calculate the areas of all of those. All 2 of them. So since it's an array list of shapes, we're going to use a for each loop, and our temporary variable is going to be of type shape. For every shape that's in the shapes list, system.out.println area equals plus s.getArea. And that's not shapes, that's supposed to be slist. My mistake. Where's that green?
I think it shows what part of your screen's getting recorded.
Well, I kind of wanted the whole thing recorded. Okay. There we go. So this is polymorphism here. We have different objects. We have squares and circles, but they're all being treated as though they are the same. We can stuff them all in a list. We can call the getArea method on all of them, but the getArea method does something custom for each kind of shape. So if you're making a drawing program that allows you to plot polygons onto the screen and move them around, then they might all inherit from a common object. And each object might have an X position and a Y position on the screen, and then a size and a, you know, how big it is and what color. But then each one may have custom attributes as well. If it's an image that's being pasted on the screen, maybe it's got some bitmap data or a pointer to a file. If it's a circle, maybe it's got the radius of the circle, you know, the thickness of the line or whatever. So that way, you could give some part of your program a list of shapes, and then it would be able to go out and update your screen and display all that stuff. Alrighty, so that is using abstract classes. There's a special kind of abstract class called an interface. Now you could only inherit from one class, and that's true of abstract classes as well. You can only have one superclass. That superclass can have another superclass, and you can make, you know, a whole chain of those. But still, if you're talking about what you are, a circle is a shape. A square is a shape. Both of them inherit from shape. And we can't say, oh, by the way, my circle is also something else, and it extends two different things. If you need that to happen, you can use what's known as an interface. An interface, all it does is define methods. Tried using the same example, so I'm trying to pop up a different one. So the way you define an interface is, instead of saying class, you drop the word class and you put the word interface there. That tells us that it's a very special kind of class. All the methods in it have to be abstract. All the variables in it have to be final, static. Which are the same thing. If they're final, that means they're, well, nah, I won't go there. I don't know if that's true or not. I think it is. Yeah, because they're constants, so they cannot differ on an item-by-item basis. So we're going to make, I guess, right up here underneath our square and stuff like that, we're going to define an interface called animal. And it has an abstract method called eat. Now, once you define something as an interface, every method in it already is abstract, so that's a superfluous keyword. We could get rid of that. So every method in an interface has to be abstract. You can leave the abstract keyword off. Every variable must be a final, a constant. static variable. So that's all an animal does, is eat and sleep. Now we're going to define another interface called pet. What do pets do? They fetch. And we're going to make two classes, one called cat and one called dog, that implement both of those interfaces. Class dog, we don't use extends with interface. We use the word implements rather than extends to inherit from an interface. As you can see, you're not really inheriting much. You're just inheriting a blueprint of stuff you have to implement. Okay, so the dog. He implements the animal class. For that to work, we have to give him an eat and a sleep function. Public void eat system.out.println nom nom. Public void sleep system.out.println snore. That's great, but what if we want to make him a pet as well? Implements animal, comma, pet. It's going to tell us that this is not a valid class because it does not implement the fetch method. So public void fetch system.out.println fetching the stick. Now let's define a cat. Easiest way is just to copy that entire thing because we know it has to have all those methods. And then change them. Paste, change. My cat, when he eats, he goes purr. When he sleeps, I don't know what he does. Twitch. Okay, when we tell the cat to fetch, no way. So an abstract method is one with no body, marked with the abstract keyword, that indicates that any class that extends, implements it, must override, provide a body for that method. So every variable in an interface must be a final static variable. That's not true of an abstract class. An abstract class can look just like a regular class. I'm not sure why you would do that with no abstract methods, but see, it can carry data. An interface cannot. So that gives us the option of doing things like this. Go down to main. I'm sorry, did everybody get the cat and the dog? Are we good? Okay. Go down to main and let's do pet p1 is equal to new cat. And then p1 dot fetch. We're going to tell the cat to go fetch. And he's going to tell us no way. Fetch? No way. Now when we type P1 and we get a list of all the methods, why don't we see eat and sleep there? Right, because he's a pet. And the only thing that the compiler knows about pets is that they have a fetch. If we wanted to be able to call eat and sleep, we better define it as an animal, or a cat in particular. So let's do animal A1 is equal to new dog. A1 dot, and our options are to eat and sleep. If you want to, you could get a hold of that pet, that fetch, by using casting. Pet P2 is equal to, we're going to cast A1 to be a pet. And then we can call P2 dot fetch. So the cat says fetch no way, and then the dog says om nom nom snore fetching the stick. So in order to convince it that our animal could fetch, we recast it as a pet. We could have just created it as a dog, and then all of those options would be available to it. Dog D1 is equal to new dog, and then we could call all three of those features. D1 dot eat, D1 dot sleep, D1 dot fetch. So why wouldn't we create them all as dogs? Well, if we wanted to be able to stick both cats and dogs into the same array list, we can't define it as an array list of cats or as an array list of dogs. We could declare it as an array list of pets or of animals. Maybe we could declare an abstract class that said abstract class blah 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 implements pets comma animals, and then we could call that critter, and then we could make an array list of critters. But we're just going to go with what we have here. Array list of pets D1, wait, P list is equal to new array list. Now anything that it knows is a pet, we can add to this list. That's an error. Oh, I forgot my parentheses at the end. Take the S off of pets. So P list dot add. I can add P1 to it because it knows it's a pet. I can add P2 to it because that's also of type pet. I can add the dog to it. But I can't add the animal reference to it. The compiler has no idea that an animal reference can also be a pet because they don't inherit one from the other. How did we fix that in the past? Up here, we cast our animal to be a pet. So if we wanted to, we could do some casting there. We could put parentheses, pet, and we can say, oh, by the way, A1 is a pet, so it's safe to add. So now we have an array list of all these different animals. And comment that one out. And then we could write the array list that would go through and call fetch on every animal we've created. For pet P in the P list, system, what, no, just P dot fetch. And you know, we can't really tell what's printing out what because we haven't been putting enough information in there. But hopefully that gives the idea. Both cats and dogs, we can call the fetch method on them. They do very different things based on whether they are defined as a cat or a dog. The same method name exhibits markedly different behavior based on the kind of data it is. That's polymorphism. Poly meaning changing and morph meaning shape. So the data is changing shape based on what kind of data it is. We're passing them all to the same method. And when we were talking about way back in the past, the idea of overriding methods, overloading methods. What is overloading methods? I don't think we've talked about it this semester. An overloaded method is when you have the same method name but with different parameter lists. That is sort of a polymorphism, but not really. We may as well give an example of that. So scroll up to the top under here. I don't even know what we're going to call this example. We're just going to call it overload example. And it takes two kinds of data. Double I don't want to say double triple, that sounds really stupid. Double times 3, which takes a double and returns 3 times double. 3 times the D. And I forgot to make it public, and I'm sure I've made another mistake. Oh, this class should not be public. You can only have one public class per file. There's still a problem. I'm not seeing it. I'm just going to type garbage. Don't bother typing this. Public double.
I think it returns with the S next before. It was supposed to be just return.
Return D times 3. All right, I don't know what I did different there than what I had before.
You had the S returns.
Oh. Duh. All right. Yeah, don't put S on the word returns. Now we're going to make another method that has the same exact name, but it accepts a different type of data. Public double, triple me, it accepts a string. For some weird reason, we want it to be able to do math on strings as well. And if that happens, it returns 3 strings concatenated to each other. So if you say triple me and you pass in hello, it's going to say hello, hello, hello. But it can't be a double. It's returning a string. So up here in main, let's create an object of overload example. Overload example OE is equal to new overload example. Why did I choose such a long name? And then system.out.println OE.triple me, and let's pass in a double. we're going to triple out the number 30, so it ought to print 90. And then we're going to call system.outline.tripleme OE dot, but we're going to pass in a string. I love Java. So it's going to say, I love Java, I love Java, I love Java. So triple of 30 is 90. That worked. Triple of I love Java is I love Java, I love Java, I love Java. Silly example, but we see that we have a method that has the same name, but it accepts different data types. That is the definition of overloading. Overloading sounds bad, it sounds dangerous. No, it's not bad at all. You're making one function name that can handle more than one kind of data. Now you don't want to go nuts and go, oh, I better also include a triple V for ints and for floats and things that can be cleanly converted. Ints can be cleanly converted to double without even any question. We wouldn't need to create a special version of triple V that accepted ints. Same with longs or floats, because they can all be converted to doubles on the fly. We don't have to even do any casting. But strings cannot be converted to doubles on the fly. So it's legit for us to create a method that accepts a string. Now maybe we should have converted that to a number, tripled it, and then returned that number back as a string rather than just print 3 copies of it. So that is overloading. Overloading is creating more than one method in a class with the same name but different parameter types. So you can make one that accepted 1 int, you can make one that accepted 2 ints, you can make one that accepted 3 ints, you can make one that accepted 1 int and 2 doubles. What you cannot do is make them accept the same type of parameters but return a different type. If you made one double that took an int and returned an int, and then you made another double that took an int, or triple me, that took an int but returned a long, it wouldn't know which one you were trying to call. It only knows which one you're trying to call by the parameter list. So the parameter lists have to differ. The return types can differ, but you can't write overloaded methods that differ only by their return types with identical parameter lists. You do this so that the method can accept different data types. Strings versus doubles or whatever. Or different numbers of types. You can make a method called add that accepted 2 numbers and return those numbers added. And then you can make one called add that accepted 3 numbers. Let's do those. Public int add int x comma int y. It returns x plus y. Hey, I left the s off this time. Then public int add int x int y int z. Return x plus y plus z. So down in main, let's call the add method first with 2 ints and then with 3 ints. System.out.println OE.add. I'm going to add 2 numbers, a 1 and a 2. Hopefully get 3. And then system.out.println OE.add, and I'm going to pass in 3 numbers, 1, 2, and 3, and hopefully get 6. Yeah, so the first one printed out of 3, the second one printed out of 6. 1 plus 2 is 3, 1 plus 2 plus 3 is 6. So the same method is accepting different numbers of parameters. If you want, you can create a method that will accept any number of parameters, but they have to all be of the same data type. And I don't think we need to talk about that. Variable length argument lists. inside the method, that argument list is treated as an array. But when you call it, you don't pass in an array, you just pass in however many values you want. So this add function could be rewritten to accept an array of ints or a variable argument list of ints. But we're not going to do that. But that's the idea behind overloading. I'm going to need to pop up a quiz about whatever chapter we were just on. That's not right. So we are pretty much done with chapter 6. So I need to upload a quiz about it. Have we talked about what a UML class diagram looks like? That's kind of sounding like we haven't. And we need to. A UML class diagram, Unified Modeling Language. Let's go ahead and download this and open it. Stands for Unified Modeling Language. It's much larger than the example we're going to give here as to what you can do with them. But at its simplest, you define a class like this. You say, I have a mouse class. And it's got 3 member variables. In UML language, they can also be called attributes. If you really want to get confused, in other places they could be called fields. These are the variables. And then the methods, which in UML are known as operations. So, I'm not going to try to trick you up by, asking you to differentiate between these 2 terms because they mean the same. So usually I'm going to say that these are variables, not attributes. And usually I'm going to say these are methods, not operations. You just need to be aware that when you get out of this class and get into some other programming discipline, you may see. So here's a mouse class. Every mouse has an age. Every mouse has a weight, and every mouse has a % growth rate. Age and weight do not have setters, but growth rate does. So you can set the growth rate of your mouse. And then every time you call grow, the weight of it increases by the growth rate, and it ages by a day. Every time you call display, it prints some information about that mouse. So we know the difference between private and public, right? If something is private, it can only be accessed from within that class. It cannot even be accessed by things that inherit from that class. If you want to inherit from things that, if you want to modify data in a superclass, you can't make it private, you better make it protected. Keeping your data private is known as encapsulation. You provide methods that can access the data, but you're keeping that data safe from unsafe operations by other programmers or yourself. It keeps the data in a good state. The class that uses your class is known as a client. This textbook is calling it a driver. Here they're creating 2 mice, Gus and Jag, and they're going to be using them, and so this is the driver class that creates those 2 mice. Gus gets a % growth rate of whatever they typed in. Jag gets a % growth rate of whatever they typed in. Then we call gus.grow, jag.grow, gus.grow. Gus grew 2 days, Jag only grew 1 day. So then when we call Gus.display, Gus ought to be a little bit bigger and a little bit older than Jag. So this is the driver class for, more traditionally in other texts, called the client class. This is a client of the mouse class. Reference variables. That's a fancy name for a variable of a class type. Mouse is a class, so when you create a mouse, Gus is a reference variable because it can reference a mouse. When you create it like that, you haven't instantiated a mouse yet, so it's referring to nothing. You might wind up using the terms reference and object interchangeably. They are almost interchangeable, but not really, because you can have more than one reference pointing to the same object. If we did mouse Gus, Gus equals new mouse, mouse Mickey, Mickey equals Gus, we haven't created two mice, we've created two references to the same mouse. Just like you can have two signs that point to the same street. It's not two separate streets, it's just two signs that point to the same street. We know how to call a method. We know what the this reference is. Here they've spiffied up the mouse class a little bit. It's still got the same member variables, age and weight and growth rate. But along with set growth rate, they've added a couple more, get age and get weight. They figure that your program may need to be able to access that information. So they added some getters. However, they did not put any setters in there. You can't just automatically change the weight of your mouse just by, saying, hey, now you're a 15-ounce mouse. That'd be a way heavy mouse.
Right?
So we know what a local variable one is. It's one that's inside a method, as opposed to a class and an instance variable. Those are parts of a class. Which ones of those are declared as static? Instance variables or class variables?
Class.
Class variables. Guaranteed exam and quiz question. We know what the return statement does. If something is declared as void, you can leave the return off. And as a matter of fact, NetBeans complains about it and gives you a warning saying that it's an unnecessary return, which I think is rude. The void return type means it's not returning any value. The empty return statement, you use that with voids. If you try to create an empty return statement with something that's expecting a data type, like an int or something, that will give you an error. Software engineering observation. Real-world programmers are often asked to maintain, fix, and improve other people's code. In doing that, they often find themselves having to examine the loops and trying to figure out how the loops terminate. It's important that the loop termination conditions are clear. If you start sticking return statements inside a loop, it's not clear how it exits. In the interest of maintainability, you should use restraint when sticking return statements inside a loop. If it makes it easier to understand, clearer, go ahead and add it. But if it makes the coding easier but doesn't make the code clearer, don't do it. Argument passing. We know what arguments are. Arguments are the values that you pass in between parentheses that fill in the parameters. This is actually pretty important. Java uses pass by value. C++ have something called pointers. And C++ and C# have the reference type, meaning that you can pass something in as a method, and not only is it just a copy of the value, it is actually the value itself, so that any changes to it modify the data. Here's an example of something that you might expect to work, but it absolutely does not. Void test me int I is equal to 3. Why is it called test me? I don't know. And then down here in main, you do int x is equal to 3, and you call test me, and you pass in x, and then you print x. No, wait, not 3, 0. What do you expect x to be after that is called? If you think 3, that's entirely good guess, but it is not correct. The reason being is that it's not passed by reference. I is not referring to the x variable. It is a copy. When we call test v, this argument fills in that variable with a copy of the data. So we could do anything we want to I, and it doesn't change the value of x at all. So it'll still print 0. There's no way to convince Java to treat x as though it were, or treat I as though it were a reference. In C# and C++, you can use special symbols or keywords to do that. X equals 0, not 3. I is a copy of what is passed in. So changes to I do not change the data in the outside code. Now, why would that be true? Why would they implement it like that? Well, what if you could change that variable? Makes sense. I want to be able to change I. What if you did this? Test me 4. How's the number 4 going to suddenly become the number 3? What would that even mean? Doesn't mean anything. This value 4 gets copied into I. I is just a copy of it. We can do anything that we want to inside that method. It does not change that 4 down here. There is a point where it gets a little bit more subtle, which is if you pass a reference in. If we do this, void test2, and it takes a student, or cat, or whatever, student S1, and we say S1's .name equals Bob. Everybody goes to this school and takes the test, gets their name changed to Bob. So down in main, if we create a new student, student me is equal to new student, me.name is equal to Mary, and then we call test2, and we pass that student in, and then we print out, whoops, that was supposed to be me. We print out me.name. What is it going to print out? It's not going to print out Mary. It's going to print out Bob. The reason for that is that these are reference types. Classes are reference types. So this is a reference to an object. It's not the object itself, it's just a reference to it. This creates a student object out here. That has the name Mary in it. And it's at address 1, 2, 3, 4, whatever. When this gets copied into there, S1 is a student at address 0, 1, 2, 3, 4. So even though S1 is just a copy of this value, me, they point to the same memory address, that means that they're both pointing to the same stuff. And if you change stuff in here, it changes it down here. So name Bob, S1, and me are pointing to the same space. And I need to put this marker up before I accidentally draw on the board. Kind of subtle. I hope that's clear. You can pass objects in as parameters, and you can change the members willy-nilly. That almost sounds like Milli Vanilli. I'm too old. Y'all don't know who Milli Vanilli is. All right. So now we're going to create something that's not going to work. This kind of did work. Since S1 is a reference to the object that was passed in, it is a copy of the me reference. Test2 can actually modify the members. What it can't do is change this. What do I mean by that? We're going to create one called test3. When you call test 3, it creates a brand new student. S1 equals new student. S1's not name is equal to Sarah. Now down here inside of main, student me is equal to new student. Me.name is equal to Mary. Test 3, me. Print me.name. Is it going to print Mary or is it going to print Sarah? It's going to print Mary. The reason why is that we can change the values of S1. We can change the members of it, but we can't change that value itself. We can't make it point to a new object because this just gets a copy of what's passed in here. Just like that number X, when we passed in a 0, it didn't change into a 3. We can make all the modifications we wanted to that variable. We can assign it to new things, but when we get out here, this still points to the original object. Is that kind of making sense?
Yeah.
Hope so. This is a good point to stop. The homework assignment is a video tutorial to follow. Inheritance, abstract classes, and interfaces. Polymorphism tutorial. Kind of the same thing we did in class. Slightly different examples. I'm sure that one of them has shapes in it, but it's got better examples than just calculating get area. So there are 3 videos. I think each one of them is about 15 minutes long. Just work through them. I forgot to put a due date on the car class, so I made it due a week from today. Well, you know, 79.
I appreciate it.
The due date of the inheritance thing should not be December 4. That gives you a little bit too long to work on it. We'll make it April 9 as well. All right, let's make a Dropbox for this, and then we're done.
That's what the dog says when you ask for fish.
All right, Dropbox in is there. I will upload the notes, which will consist entirely of the source code plus these extra notes that I tacked on at the bottom, hoping that they will make sense. I would recommend reading these chapters